At MIT, Seth Lloyd is one of many researchers trying to harness quantum mechanics in powerful new ways.
Quantum mechanics is weird. That's just the way it is. So, life is dealing us weird lemons. Can we make some weird lemonade from this?
Lloyd's weird lemonade comes in the form of a quantum computer.
These are the guts of a quantum computer.
This gold and brass contraption might not look anything like your familiar laptop, but at its heart, it speaks the same language: binary code, a computer language spelled out in zeros and ones, called bits.
So the smallest chunk of information is a bit. And what a computer does is simply busts up the information to the smallest chunks and then flips them really, really, really rapidly.
This quantum computer speaks in bits, but unlike a conventional bit, which at any moment can be either 0 or 1, a quantum bit is much more flexible.
Something here can be a bit. Here is 0, there is 1. That's a bit of information. So if you can have something that's here and there at the same time, then you have a quantum bit or qubit.
Just as an electron can be a fuzzy mixture of spinning clockwise and counterclockwise, a quantum bit can be a fuzzy mixture of being a 0 and a 1. And so a qubit can multitask.
Then it means you can do computations in ways that our classical brains could not have dreamed of.
In theory, quantum bits could be made from anything that acts in a quantum way, like an electron or an atom. The qubits at the heart of this computer are tiny superconducting circuits built with nanotechnology that can run in two directions at once. Since quantum bits are so good at multitasking, if we can figure out how to get qubits to work together to solve problems, our computing power could explode exponentially. To get a feel for why a quantum computer would be so powerful, imagine being trapped in the middle of a hedge maze. What you'd want is to find the way out as fast as possible. The problem is there are so many options. And I just have to try them out, one at a time. That means I'm going to hit lots of dead ends, go down lots of blind alleys, and make lots of wrong turns before I finally get lucky and find the exit. And that's pretty much how today's computers solve problems. Though they do it very quickly, they only carry out one task at a time, just like I can only investigate one path at a time in the maze. But if I could try all the possibilities at once, it would be a different story. And that's kind of how quantum computing works. Since particles can, in a sense, be in many places at once, the computer could investigate a huge number of paths or solutions at the same time and find the correct one in a snap. Now, a maze like this only has a limited number of routes to explore, so a conventional computer could find the way out pretty quickly. But imagine a problem with millions or billions of variables, like predicting the weather far in advance. We might be able to forecast natural disasters like earthquakes or tornadoes. Solving that kind of problem right now would be impossible because it would take a ridiculously huge computer. But a quantum computer could get the job done with just a few hundred atoms. And so the brain of that computer, it would be smaller than a grain of sand. There's no doubt we're getting better and better at harnessing the power of the quantum world. And who knows where that could take us.